Good afternoon, class.
Good afternoon, sir.
I hope you had your lunch.
Yes.
Okay, thank you. So I would like us to make arrangements for the class so that you can start. So that is good. So before we begin, I will take the roll call so that I know if everybody is in. Kennedy?
Present.
Banada?
Present.
Uleny?
Present.
Dolphin?
Present.
That's good. I can see everybody is in. So during the last class, we were covering connections of resistors. Either one of them was in series. Who can remind us the other case? Yes?
I will look at the connection in parallel.
Good. Clap for him. Then which is the other case?
Connection in series.
Connection in series. And the last case?
Connection in series parallel.
Good. So that's very good. We are going to continue with the same unit of competency. What is today's date? Yes, Kennedy? 20th?
2024.
So we are continuing with the unit of competency, which was apply electrical principles. So today's session title is Kirchhoff's laws. Our learning outcome our learning outcomes. The first one is we're going to state Kirchhoff's laws. And then the second learning outcome, we are going to apply Kirchhoff's laws on simple DC circuit. On simple DC circuits. Now, we have two Kirchhoff's laws. One of them is current law. So which is the other case? Voltage. Good. So we are going to start with the first one, which is current law. So we're going to do an activity here. I'm going to issue you with these papers. With this one. So I'm going to remain with one. So you read what you have.
The algebraic.
The algebraic. Who has sum? Sum. Who has off? Off. Who has current? Who has is? Entering? Is? Which one do you have? Node. Entering a node. And what else? Unload. Me, I have is 0. So I'm going to complete the statement as you raise those papers. So when I say the algebraic, you raise the paper.
The algebraic.
Sum of current entering a node is 0. That is the definition of current law. So that means that if you have the node, as we have said, and you have current entering, and the other living, when you add, the result here is 0. That is Kirchhoff's current law. So we go to voltage law. I would like you to think, then you pair and you share on Kirchhoff's voltage law. So write on the piece of paper. Good. Now exchange with your neighbor, exchange with the neighbor group, That's good. Now, who can state for us what is Kirchhoff's voltage law? What is voltage? Yes, Bernarda?
The sum of the voltage drop.
The sum of the voltage drop
In a closed loop circuit is equals to the voltage being supplied to that loop.
Good, clap for Banana. So we have a circuit, then you have some resistors as we saw in the last class. So this is the EMF, this is maybe R1, this is R2, then you have a current flowing. As Banana has said, when you take the drop here, which is IR1 plus the drop here, which is IR2, will be equal to the source voltage. So this is the Kirchhoff's voltage law. So I would like somebody to come and help me pin this chart. Thank you. Now, from the chart, we have already defined Kirchhoff's current law and Kirchhoff's voltage law. So our first objective is met. We go to the application of Kirchhoff's current law. Now note down on your books. From this diagram, we have currents entering and currents leaving. So if I2 is 1 ampere, when you look at the diagram, I3 is 1 ampere and I4 is also 1 ampere. You are supposed to get I5 given I1 is also 1 ampere. It's also 1 ampere. So write down how to get I5. So note down. So I can see everybody has gotten the answer. So Kennedy, what is the value for I5?
I5.
Yes. What answer did you get?
Got 5.
5 amperes. Good. Clap for Kennedy. The next case, we are going to work out the Kirchhoff's voltage law. If we have this current as 2 amperes and the resistance is 2 and that resistor is 2. What is the value for E? What is the value of E? You can also write that down very fast. Yes, Odeni? 4, good. Clap for Odeni. Any contrary answer? Good, everybody has gotten. So it is 4 volts. Now, the second objective is met. Now, what have we learned today? Yes?
We have stated the 2 Kirchhoff's laws.
Good.
And the application of Kirchhoff's law.
Good. What else? What else?
How to calculate the current law and the voltage law.
That's good. Now, before we finalize the lesson, I'd like to give you an assignment. So you can note this down. For the circuit shown, on the chart, if R1 is 1 amp, R2 is 1 amp, and current is 2 amperes, determine the value of E. That assignment is due the next class. The max is 5 marks. The next class is tomorrow morning. So I believe everybody will have done that assignment when we meet again.
Yes.
Any question at that point? If there's no question, thank you very much. See you during the next class.
Thank you.